Imagine looking up at the night sky and seeing a flash so bright it rivals the sun, followed by a silent, shimmering curtain of neon colors dancing across the horizon. It looks like the most beautiful aurora you have ever seen, but within minutes, your smartphone goes dark. The streetlights flicker and extinguish. Every GPS navigation system on the planet begins to spin wildly before failing completely. This is not a scene from a science fiction movie set on a distant planet. This is the immediate reality of what happens when a nuclear conflict extends beyond our atmosphere into the vacuum of space. We often think of nuclear war as something that happens on the ground, destroying cities and landscapes, but the most devastating and long-lasting effects might actually occur hundreds of miles above our heads, in the silent, fragile environment of Earth's orbit. If the heavens become a battlefield, the modern world as we know it doesn't just stumble, it essentially gets deleted. We are going to dive deep into the physics, the technology, and the terrifying consequences of high-altitude nuclear explosions. We will explore why space is the ultimate high ground, how a single device could send us back to the 19th century, and why the orbital environment might never recover. To understand why a nuclear explosion in space is so different from one on Earth, we first have to talk about the medium. On Earth, a nuclear blast is devastating because of the atmosphere. When a weapon detonates, it heats the air to millions of degrees, creating a massive pressure wave or a blast wave that levels everything in its path. It creates a fireball that rises like a mushroom cloud. But in space, there is no air. There is no medium for a blast wave to travel through. If you were standing near a nuclear explosion in a vacuum, you wouldn't feel a thumping shockwave. Instead, you would be hit by something much more subtle and far more lethal, a massive, instantaneous burst of high-energy radiation, mostly in the form of X-rays and gamma rays. Without an atmosphere to absorb this energy, these rays travel for hundreds of miles at the speed of light. This is the first major difference. In space, a nuclear weapon is essentially a giant flashbulb of ionizing radiation that can disable objects over vast distances almost instantly. The most famous real-world example of this was a test conducted by the United States in 1962 called Starfish Prime. They launched a 1.4 megaton warhead into space and detonated it 250 miles above the Pacific Ocean. The results were far more dramatic than anyone had predicted. Even though the blast was hundreds of miles up, it blew out streetlights in Hawaii, disrupted telephone systems, and created an artificial radiation belt around the Earth that lasted for years. This leads us to the most terrifying weaponized effect of an orbital detonation, the electromagnetic pulse, or EMP. When those gamma rays from the nuclear blast hit the upper layers of Earth's atmosphere, they strip electrons away from air molecules. These electrons are then accelerated by the Earth's magnetic field, creating a massive pulse of electromagnetic energy. It is like a lightning strike that happens everywhere at once. This pulse surges through power lines, telecommunications cables, and every piece of unshielded electronics, overloading circuits and frying microchips. A single high-altitude burst over the center of North America or Europe could effectively shut down the entire power grid of a continent in a fraction of a second. But the effect on the ground is only half the story. The impact on space infrastructure itself is where the true long-term nightmare begins. Currently, we live in a world that is completely dependent on an invisible web of satellites. From the GPS that tells your Amazon delivery driver where you live, to the high-speed banking transactions that keep the global economy from collapsing, to the weather satellites that warn us of hurricanes. In a nuclear space conflict, these satellites are sitting ducks. The radiation from a blast doesn't just fry the electronics inside a satellite, it can also physically damage the solar panels and even heat the structure of the spacecraft to the point of failure. But there is a secondary effect that is even worse. After the initial burst of radiation, the Earth's magnetic field traps the highly charged particles released by the explosion. This creates a man-made radiation belt, similar to the natural Van Allen belts, but much more intense. Any satellite passing through this belt will be bombarded by high-energy electrons. This process is called satellite darkening. It wouldn't necessarily destroy the satellite instantly, but it would degrade its components so quickly that a satellite designed to last 15 years might fail in 15 days. In a matter of weeks, the orbital highways of Earth could become a graveyard of dead, silent machinery. This brings us to one of the most significant risks in space operations, something known as the Kessler syndrome. Normally, we think of space as big, and it is, but the useful orbits are actually quite crowded. There are thousands of active satellites and tens of thousands of pieces of tracked space debris. If a nuclear explosion destroys a cluster of satellites, it doesn't just vaporize them, it turns them into thousands of smaller fragments of metal, glass, and plastic. Because there is no air resistance in space, these fragments don't fall back to Earth immediately. They stay in orbit, traveling at speeds of 17,000 miles per hour. If one of these fragments hits another satellite, it shatters that satellite too, creating even more debris. A nuclear detonation in space could act as the ultimate trigger for a runaway chain reaction of collisions. Within a short period, the low Earth orbit could become so clogged with high-speed shrapnel that it becomes unusable for centuries. We call this the orbital prison scenario. If this happens, mankind is effectively locked on Earth. No more space stations, no more missions to Mars, no more moon bases. The threshold to space would be a wall of lethal, invisible bullets. For those interested in the future of space finance and the burgeoning space economy, this scenario is a total wipeout. We are currently seeing a massive influx of private capital into space companies. SpaceX, Blue Origin, and countless startups are betting on a future where space is a hub for tourism, mining, and global connectivity. A nuclear conflict in space would wipe out trillions of dollars in assets overnight. It wouldn't just be the loss of the physical satellites. It would be the loss of the entire insurance market for space, the collapse of communication stocks, and the end of any private investment in orbital infrastructure for the foreseeable future. Space is currently a high-risk, high-reward frontier, but a nuclear event turns it into a zero-reward, absolute loss zone. The economic impact would ripple through the global market as the synchronized timing provided by GPS satellites fails, causing chaos in everything from energy grids to stock market high-frequency trading. Now let's talk about the military strategy of why a nation would even do this. It seems crazy to destroy the very environment you want to use, right? However, in a conflict between a spacefaring superpower and a less advanced nation, or even between two superpowers, the tactical advantage of blinding your opponent is immense. If you can take out an enemy's eyes in the sky, you can hide your troop movements, protect your own missile launches from early detection, and disrupt their ability to coordinate a counterattack. A nuclear weapon is the ultimate area effect weapon. You don't need a precision missile to take out one satellite if you can take out an entire constellation with one blast. The temptation to use such a weapon as a defensive measure to level the playing field is a major concern for global security analysts. This is why international treaties like the Outer Space Treaty of 1967 exist, which explicitly bans the placement of weapons of mass destruction in orbit. The treaties are only as strong as the people who sign them, and in a state of total war, many fear these rules would be the first things discarded. The physical beauty of a space detonation is a haunting detail. When Starfish Prime went off, people in New Zealand and throughout the Pacific reported seeing incredible colors in the sky. This happens because the high-energy particles interact with the atmosphere, causing it to glow. But this glow is the sign of a silent war on our technology. The atmosphere literally becomes a conductor. This can cause massive surges in long-range communication systems. For days after a series of high-altitude bursts, radio communication would be nearly impossible across large parts of the globe. This would isolate nations, leading to further misunderstandings and potentially more escalation. In a nuclear war, communication is the only thing that can stop total annihilation. By taking that out through space detonations, you are effectively cutting the brake lines of a runaway train. We also have to consider the impact on the International Space Station and future habitats like the Lunar Gateway. For the astronauts currently on board the ISS, a nuclear detonation in space is an immediate life safety event. Even if the station is not in the direct line of sight of the radiation burst, the sudden increase in the surrounding radiation environment could exceed the shielding capacity of the station. Astronauts would have to retreat to the most shielded parts of the station, likely the Russian segment or their return capsules, and hope they can evacuate before their life support systems fail. The increase in radiation would dramatically increase the risk of long-term health issues and could make prolonged stays in orbit impossible. A space-based nuclear war isn't just a war on machines. It is a war on the human presence in the final frontier. Let's look at the long-term environmental impact on the space near Earth. The natural radiation environment around our planet is carefully balanced. By adding massive amounts of artificial radiation, we could permanently alter the Earth's magnetosphere. This could affect not just our technology, but potentially the atmosphere itself over long periods. While it wouldn't be as direct as the radioactive fallout we see on the ground, the orbital fallout of charged particles would persist for years, making any attempt to launch new satellites a suicidal mission for the electronics. We would be forced to develop entirely new types of radiation-hardened technology, which is orders of magnitude more expensive and less capable than the consumer-grade tech we currently use in satellites like Starlink. The cost of doing business in space would skyrocket, likely ending the era of cheap, accessible space for everyone. For the science-minded and space enthusiasts listening, think about the Hubble Space Telescope or the newer James Webb Space Telescope. While James Webb is far away at the L2 point, many of our most important scientific assets are in Earth orbit. A nuclear conflict in space would be like burning the Great Library of Alexandria. We would lose decades of scientific data and the ability to look out into the universe. The sensors on these telescopes are incredibly sensitive. A burst of radiation from a nuclear weapon would be like shining a high-power laser into a human eye. It would permanently blind the sensors, rendering these billion-dollar instruments useless. We would be looking at a dark age of astronomy, where our view of the cosmos is obscured by the debris and radiation of our own making. What about the threat of nuclear-powered satellites? Some satellites actually use small nuclear reactors or radioisotope thermoelectric generators for power. If these are hit by a nuclear weapon or shattered by debris, we could see radioactive material re-entering the atmosphere and raining down as fallout. While the amount of material is small compared to a ground-based explosion, it adds another layer of complexity to the disaster. The re-entry of radioactive debris could contaminate areas on the ground, leading to long-term health risks and ecological damage. It turns a space war into a subtle, slow-motion disaster for the surface of the planet. Is there any way to defend against this? Not easily. Hardening a satellite against a nuclear EMP and direct radiation is incredibly difficult. It requires heavy shielding, usually made of lead or other dense materials, which adds weight. In the rocket business, weight is money. Every pound of shielding you add is a pound of scientific equipment or communication hardware you have to leave behind. Most commercial satellites have almost zero protection against a nuclear event. Even military satellites, which are more resilient, are only designed to survive at certain distances. There is no such thing as a nuclear-proof satellite. The only real defense is deterrence and the international realization that a war in space is a war with no winners. If you destroy the enemy's space assets, you almost certainly destroy your own in the process due to the shared environment of orbit. It is the ultimate manifestation of mutual assured destruction. As we look toward 2026 and beyond, the militarization of space is becoming a hot topic in global politics. New space commands are being formed by major world powers. They are developing anti-satellite missiles, laser weapons, and even stalker satellites that can maneuver close to an opponent's craft. While these are currently conventional weapons, the transition to nuclear-tipped interceptors is a dark possibility if tensions reach a breaking point. A nuclear-tipped interceptor is appealing from a purely military standpoint because it doesn't need to actually hit the target. It just needs to get close. In the vastness of space, hitting a target traveling thousands of miles per hour with a kinetic slug is like trying to hit a speeding bullet with another bullet. A nuclear blast, however, fills a massive volume of space with lethal energy, making a hit much easier to achieve. The psychological impact of such an event cannot be overstated. For the first time in history, the entire world would be able to see the evidence of a nuclear war just by looking at the night sky. The artificial auroras and the disappearing stars of our satellites would be a constant reminder of the failure of human diplomacy. On the ground, the immediate collapse of the internet and power grids would lead to mass panic. Without GPS, planes would be grounded, ships would be lost at sea, and the global supply chain would grind to a halt. We often don't realize how much our physical survival depends on these orbital machines until they are gone. Food distribution, water management, and emergency services all rely on the data and timing signals provided by space. For those of you invested in the future of the human race as a multiplanetary species, a space-based nuclear war is the ultimate setback. It closes the window of opportunity. To reach the Moon or Mars, we need a clear and safe path through Earth's orbit. If we turn that path into a minefield of radiation and shrapnel, we might find ourselves grounded for many generations. The resources required to clean up space debris are currently non-existent. We don't even have a proven way to remove a single large derelict satellite, let alone millions of tiny lethal fragments. A nuclear space war doesn't just damage the present, it steals the future. It takes the dreams of generations who looked at the stars and turns them into a nightmare of isolation. The interconnectedness of our world means that a conflict in space is not a localized event. It is a global catastrophe. If a war starts in the Pacific or Europe, it stays there for a while. If a war starts in space, its effects are felt everywhere simultaneously. There is no away in orbit. We all share the same sky, the same magnetic field, and the same orbital paths. This shared vulnerability should be our greatest protection, but as history has shown, when nations feel their survival is at stake, they often choose the scorched earth policy. In this case, it would be a scorched sky policy. Thinking about the financial side again, the insurance industry would be the first to collapse. No one could afford to cover the risk of space launches in an environment contaminated by nuclear debris. The entire concept of space as a service would vanish. Companies that provide satellite imagery for agriculture, allowing farmers to optimize their crops, would go out of business. This would lead to a decrease in global food production efficiency, potentially causing famines in vulnerable regions. The cascade of failures starts in the cold vacuum of space and ends on the dinner tables of people who didn't even know what a satellite was. We must also think about the dark satellites. Governments have classified satellites that we don't even know the purpose of. Many of these are likely part of the nuclear command and control system. Detonating a nuclear weapon in space might inadvertently trigger a full-scale ground-based nuclear exchange if a nation believes its doomsday communication links are being targeted. The margin for error in space is zero. A mistake, a rogue satellite, or an overreaction could lead to a chain of events that no one can stop. The lack of clear communication and the high speed of orbital mechanics mean that decisions often have to be made in seconds by automated systems. If those systems are being bombarded by radiation and EMP pulses, their decisions might not be the right ones. In the end, the question isn't just about what happens to the technology, it's about what happens to us. Are we a species that is mature enough to inhabit the heavens, or are we going to bring our oldest and most destructive habits into the new frontier? Space offers us a chance for a fresh start, a place where international cooperation has been the norm for decades. The International Space Station is a miracle of diplomacy, where people from nations that are often at odds on the ground work together to survive and explore. A nuclear war in space would be the ultimate betrayal of that spirit. It would take the one place where we have shown the best of ourselves and fill it with the worst of ourselves. The physics of a space-based nuclear war are clear. Huge bursts of radiation, massive electromagnetic pulses, the creation of persistent radiation belts, and the potential for a runaway debris chain reaction. The technology we rely on every day would be the first thing to go. Our power grids would fail, our communications would vanish, and our window to the universe would be slammed shut. The economic cost would be measured in the trillions, and the human cost would be measured in a lost future and a crippled civilization. Space is not a distant place that doesn't affect you. It is the ceiling of your home, the infrastructure of your life, and the future of your children. As we move forward into this new age of space exploration and commercialization, it is vital that we remain aware of these risks. We cannot afford to be complacent. Public interest in space must include an interest in space peace. We must advocate for the strengthening of international treaties and the development of technologies that can mitigate the effects of space debris and radiation. We must demand that our leaders see space not as a battlefield, but as a sanctuary for science, exploration, and the common good of all humanity. The stakes are literally higher than they have ever been. So the next time you look up at the stars, remember that they are more than just pretty lights. They are a reminder of where we come from and where we can go. Our satellites are the tiny, brave scouts we have sent out into the darkness to help us build a better world here on the ground. To turn that darkness into a theater of nuclear war is to turn away from our greatest potential. Let's make sure the only flashes we ever see in the night sky are the shooting stars of natural debris and the steady, peaceful glint of our satellites, working silently to keep our world connected and our future bright. Space is the one arena where we cannot afford a single mistake. Let's keep it clear, let's keep it safe, and let's keep it for everyone. The alternative is a silent, dark, and lonely planet, locked behind a wall of our own making, wondering what happened to the dreams we used to have when we looked at the moon. Keep your eyes on the stars, but keep your mind on the fragile balance that keeps us all alive.